An important skill when looking at number lines or graphs is being able to determine intervals between marks on a number line. You're not always given a number at each mark, so you need to know what that distance is. So that's called an interval. Sometimes you'll need to determine the interval or distance between two marks on a number line. So to do that, we're going to look at the two numbers that they did give us. For example, 0 and 10. What is the distance between those? That one's pretty easy because it's just 10, but the math that's involved is the distance is subtraction, the absolute value of the difference. So 10 minus 0 is 10, or 20 minus 10 is 10. So if we know that the distance from here to here is 10, then what we're going to do is look at how many marks are between those. To do that, you're going to start at one and count to the other. This section here, this interval of 10, is divided into 1, 2, 3, 4, 5 sections. So what we're going to do is, like I said, I actually used the word, I said it is divided or broken into 5 equal groups. So we're going to take that whole distance, 10, and we're going to divide by how many sections it's divided into, 5. And what that gives us is the interval between each one of these marks. So 0, this will be 2, 4, 6, 8, and that gets me to 10. So I always go all the way to the next mark to make sure that I have done that correctly. From 10 to 20, these are still going by 2. On a number line, every interval should be the same. 18, 20, okay, 22. Alright, so if we needed to know where this point was at, it was at 8. Okay, let's look at another example. So like I said, sometimes you're not going to have it starting at 0, so we need to determine the distance by using subtraction. So from here to here, 30 minus 15 is 15. So my distance from here to here is 15. And then how many pieces is this section broken into? 1, 2, 3, 4, 5. So again, I had 5 equal pieces. So 15 divided by 5, and so this time it's going to be 3. So that means my interval here is going by 3's. So 15 plus 3 is 18, 21, 24, 27, 30. And again, I always want to double check, make sure I land on the correct number. So to figure out where this point is at, I'm going to continue to count by 3's. 33, 36, 39, 42, and that'll land me on 45. Okay, so this point was at 39. Okay, sometimes I'm going to give you a couple examples here where my distance between the points is actually 1. Okay, so what I'm going to need to decide is what this is going to be pieces of a whole number. From here to here is one whole. So this is going to kind of review your concept of fractions. So in one whole unit here, I have it divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. So if I have 1 and I divide by 10, it's going to give me 1/10. Now, tenths can be written either as a fraction or as a decimal. So I'm going to kind of show you both, 1/10 or 1/10. Okay, those are the same. So here would be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 0.10 actually gets you to 1. So this would be 1.1 and so forth. Again, I could also write that as fractions. 1/10, 2/10, which is actually equal to 1/5, 3/10, okay, and so forth. So in this situation, because I'm dealing with tenths, I could have chosen to write these either as fractions or as decimals. Okay, so this particular point was at 3/10 or 3/10. Again, you say those the same way. Alright, let's look at one more example together. Between 3 and 4, there's only 1. The distance is 1. So again, I've got something that's breaking a whole into pieces. So let's see how many sections I have. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this time 1 divided by 8 is 1/8. Now, I cannot easily change eighths to decimals. So I would probably, if I was trying to graph something that was a decimal or give the location as a decimal, I might use my calculator for eighths. So this would be 3 and 1/8, 3 and 2/8. Now remember, I can simplify this. Divide by 2 divided by 2. This is 3 and 1/4, or 1/4. 3 and 3/8. 3 and 4/8. Now again, 4/8 can be simplified. This would be 3 and 1/2. This is 3 and 5/8. This is 3 and 6/8. Or again, 6 and 8 can both be divided by 2. So this is 3 and 3/4. Okay, this is 3 and 7/8. And then 3 and 8/8, that actually is going to, the 8/8 becomes 1, so there's your whole 4. Okay? I want you to also look, when we simplified this, you know, this was divided into eighths. However, if you look between 3 and 4, if you look at the ones that I've put above, that's actually 1, you know, from here to here. Let me show it in a different way. If I looked at between 3 and 4, if I go every other mark, there's 1, 2, 3, 4. So if I counted them this way, it's 3 and 1, 2, 3/4. So 3 and 3/4, 3 and 6/8, those are equivalent.